Hi, my name is Vitaly and I am a quantitative developer, and in this video I like to target quantitative traders or discretionary traders to show them quantitative approach that supports their trading decision. Essentially, I will be looking at the historical volatility of S&P 500 and simulate day trading odds. You can do the same analysis with your asset. Any instrument you like to analyze, you can use the code, and I show you in shortly how to do it. Using Python programming language, so you don't have to worry to install anything locally. We will be using Google Colab. Google Colab is essentially a Jupyter notebook environment that helps developer to write their code, write documentation, and store their output, and also share the notebooks with other people that can have a look at it and replicate or improve whatever you want. So if you're interested to see the technical approach, the quantitative approach, how it's done, so let's dive in and show you how to do it in programming.
Okay, now we are seeing the Jupyter notebook opened via the Google Colab, as you can see in the link above. So in this practical example, I want to walk you through a distribution and odds calculation, which I presented or gave you a bigger picture in the introduction. So first of all, we do the distribution and odds calculation. So the professional trader starts with data analysis. So we will cover the points how to get and process data, define odds of making or losing certain amount of money for any given asset and for any given time interval. So you can select the time interval. With empirical statistics, we begin to understand the potential upside and downside of trading particular asset. And numbers will speak for themselves, so we will separate the signal from the noise when we make our trading decision. So why is data important? So data tells you the opportunities in any given market for any given asset and for any time horizon. So what we are going to do is to look at the historical volatility. This approach can be applied to any market and asset class. So historical volatility is a good indicator for what your opportunities are and what you should expect in terms of your odds of making certain amount of money. So data will reveal the behavior of the asset you are going to trade, simulating day trading odds. And at the end we will do the simulation. Okay. So getting the data is simple. You first import pandas data reader data as web. This package is responsible to get data from Yahoo source or any other source. You can see the documentation of this package, which source you can select. So matplotlib pyplot we use for visualization. Okay, so run this cell. So now in this cell you kind of set the parameters. So for the ticker we select the S&P 500. If you Google at Yahoo what the ticker is for S&P 500, it will give you GSPC. So you type that here, then the source we select Yahoo, we have a start date 2000 first, and then all these parameters you can use and tweak as you want. It's just an example, right? So next step is to pull the data from the source. So like I said, we use the data pandas reader to pull the data. Okay, so we pull the data, and what we do after it has downloaded from the source, we can visualize it, the first columns. The head shows only the columns, right? The number of columns. So you can change it if you say, I want to see 10. You just put here 10. By default it is 5. Okay, let's keep it to default value. So next, so you can see now different columns for high, for low, for open close, volume, and adjusted close. We are interested only at adjusted close. So we select the adjusted close column like this, and we also want to rename it and call it then close, and again we just display the 5 columns to see if it has been done correctly. Okay, Nice. So next step is calculate daily returns and create a new column with the daily returns. Okay. So the way you do it, you use the percentage change function. So you select the column, right? In that case, close. That is the output. So you select close column and you perform percentage change. And the first value will be NA. So you want to drop the NA. That's why they drop NA. And then you display again. Okay. Now we have the returns. Let's look at the returns and see the distribution of the returns. Okay, that's, you can see. So you can see based on the returns that majority of the returns are around 0, but we will make a more detailed analysis later. So creating intervals. Now let's customize the intervals. We don't need necessarily to see up to minus 10% or up to 10%. We can say, okay, -2, what are the returns below 2% or above 2%, right? So you can create your custom intervals here. You can say -2, 1.5, -1.5, and so on, in 0.5% steps. And so create this, and then I have a custom function that now goes through the data frame and selects and filters out for specific interval and counts the amount of frequency, like counts the amount it happens for that specific return, right? That's the function. So you can look at the function, see what is done. Basically Python is quite easy to read, to understand. So return of frequencies. So now we can visualize again and see different buckets. Okay, here we see that we have actually way bigger tails than compared to normal distribution, right? So that's one way to do it. So now let's take, that's just frequencies of the whole occurrence of the whole data we have pulled from Yahoo. So let's see the probabilities of specific returns, right? And you can just take that frequency and divide by the total number of the length of the data frame. So now you see the probabilities. Okay, so if you want to change from probabilities to odds of winning, so we can do that. So if you are not familiar with odds of winning, it is basically the odds of an event is the probability of it happening divided by the probability of it not happening, right? So the odds of flipping a coin and getting ahead is 1, which comes from 50% probability of getting ahead divided by the 50% probability of getting a tail. Also, odds of 1 are sometimes also known as evens, since the evens are equally likely or evenly balanced. The odds of throwing a die, so another example here, the odds of throwing a die and getting a 6 is 1/6 divided by 5/6, which comes from 1/5, popularly known as 1-5 or 5-1 against. So you have to divide your odds against the odds not happening in. Okay, so you can look at this, read again, and try to understand. And so what I'm doing here is basically making that specific calculations. I divide against the odds of probability of not happening in, and then I rename it. So first of all, basically here I'm calculating what is the probability divided by the probability not happening, and then you do again 1 divided by that outcome, and you get the values. You loop through the values, and then you create a string and saying that outcome round to 2 digits to 1 against, right? And then assign to new index, and you plot the values, and then you have, instead of the intervals, you can say that is my odds to have that specific probability outcome. Okay, so descriptive statistic of returns. So how can we do simple statistic returns? There is a function in pandas which called describe that gives you the descriptive statistic. So you have the count. So if we have 4,778 samples of the data, the mean of the data is 0%, the standard deviation is 1.2%, the minimum return you can get -9%, and the max 11.5%. So you can see that yeah. So let's look at the cumulative returns. So cumulative returns, you have essentially to sort all your data and divide by total amount of data, right? You can see first you sort your X, and then you arrange it and you divide by the length of the data. So you say what is here, okay, and then we do the visualization, visual cumulative returns. You have like an S shape. It's very helpful to understand what is the probability of getting, for example, here 0% of returns. So if you go up here 0% and you go left, you kind of have around 37%, saying that 37% of the time your returns are below 0, and vice versa 63% you have probability bigger than 0 of returns. Probability of positive and negative returns. So okay, so how do you calculate? First of all, you create a filter for positive and negative and 0 returns. Then you filter out, you count, and you divide by the total amount of data. So and then you calculate. So you can basically see that positive probability is around 53%, negative probability around 46.7%, and 0 probability is around 6%, right? 0.6%. Then we just check. The statement just checks that the probability is 1. So the sum of all probabilities must be 100%. So calculate average positive and negative return. So how do you do it? You take the mean return of the positive and multiply by the positive return, the probability of positive returns, and then you have your average return. Okay. So next step is to calculate volatility, standard deviation, and volatility, standard deviation, and STD is the same thing. It's just you can use different words for it. Okay, and we calculate this from the empirical distribution. So okay, so we can see the upper standard deviations is 1.22%, the second is 2.4, the third is 3.67, and negative is almost symmetric. You can see. Count values of how many between. Okay, so now let's try to understand how many observations are between 1 standard deviation, 2 standard deviation, 3 standard deviation, so we can use that values to compare against the normal distribution. Okay, so if we calculate that, you can see that for our empirical values, we get for 1 standard deviation 78%, 78.9, almost 80%, right? So if you compare to normal distribution, under normal distribution, the values between 1 standard deviation come 68%. Right. So for 2 standard deviation of probability we have 94.8, where for normal standard deviation we have already 95. Okay, so we capture under normal distribution we will capture almost 95%. So 3 standard deviation for the empirical is 98.32, and for the normal is 99.7. So you can clearly see that majority of the data under empirical observation is in 1 standard deviation, and the further we go out, like 3, 4, and 5 standard deviation, the less we account for the empirical. And the normal distribution is actually has way thinner tails in comparing to the empirical distribution. So if you see now, if you compare now adding commission to the trading and calculate the positive average return, negative, you can see that for day trading it's not really good to trade S&P, as you would overall be on the losing side. Even if you win, the commission will eat your profits, right? So day trading is not recommended for S&P 500. So takeaways. Looking at the distribution, we can see that 80% of the time there is barely no volatility. That makes it way harder to generate returns, especially if you have to account for commission costs. Therefore, opportunities are minimal to make money doing day trading S&P 500. Solution: increase your time horizon to improve your odds to make some money, right? But here you can go through the same analysis and change the time horizon. Instead of having daily sampling, you can use weekly, monthly, and so on. Empirical distribution of S&P 500 starts accounting less for higher standard deviation. That indicates fatter tails in comparison to normal distribution. The difference becomes more significant if going more and more out, having more extreme moves than predicted by normality. So that means we have greater risk. There are likely more days that you can be wiped out of your position or account. You can use that approach to apply to any asset and also change the time horizon to weekly or monthly data, as I said before. So if you have any question and you don't understand something, or I can explain something better, just reach me out. Here's my email, and also you can connect with me on the LinkedIn account, and also subscribe to my channel so I can create more videos about quantitative approach to trading. Okay, thank you very much.